Okay, finally we're going to cover an aspect of cognition that bridges across all these senses, and that is our cognitive skill of selectively paying attention to some things and ignoring others. So we'll talk about this. This is what I research in my lab and find quite fascinating. And so you can picture attention in terms of this metaphor of a stage at a theater where everything is dark except something that's being illuminated by a spotlight. So the other distracting elements of the stage are being inhibited, and the important, relevant piece of information for the play or the show is being illuminated or excited. And so we can think of attention in the same way that when I tell you, for instance, now to pay attention to the feeling of your socks on your feet, your spotlight of attention can shift and boost the processing of the incoming sensory information from your feet. If I tell you, for instance, to ignore the sound of the humming in your room and the sound of the tick-tock of your clock, you can make an effort to not illuminate those with the spotlight of attention and inhibit them, and they'll have less impact on your processing. And so when we think about this metaphor, it's also good to think about the aspects of the metaphor, and that one is the objects being illuminated themselves. So for instance, we could pay attention to a cat, or to the sound of this clock, or to the color of this wall, or to the shape of this TV. And then also we should think about the spotlight operator themselves, that something in our brain has to move around this extra processing and has to decide how to allocate this resource of attention so that we can do the things we want to do. And so we'll talk about both of those, the objects of attention and also the control of attention. So we can think about attention maybe in terms of a busy, complicated scene that we look at every day. So if I tell you to find someone wearing a green shirt, you can see how your eyes would move around an image like this and look from person to person. This is a picture of my school in Edmonton growing up here. And so you can see a friend, you can see a friend over here. Your attention moves around an image like this. You don't have the ability to process each of these people in the scene all at the same time. You have to move your vision and your processing around. One reason that we have to move our attention around is we have these foveas in our eyes, so we can only really see the details of someone's face when we're looking right at the face. And so if I want to try to find myself, I think I'm right here, I have to look around at all these people. I notice a lot of these are the friends that I went to school with, so I was close to the right area. Right? But in order to then look at these people or these people, we have to explicitly move our eyes to new locations in the scene. And while we're doing that, we can ignore whole other sections of the scene. If I tell you now to look for a purple jacket, now you can ignore the green things that you were just paying attention to. So we can think about attention in this way as well. One way that we study attention in the lab is by tracking where people look, as I just indicated. So we can use eye trackers, and we can overlay that with a video they might see or a video of where they were looking, and we can get these heat maps of where people look most often. So advertisers, for instance, might use these to investigate if their commercials are effectively bringing people's attention to the products or to other less important aspects of the commercial. So we can track where people are looking. But there's another aspect of our attention, and that's that we can pay attention to places where we're not looking. So our attention and our eye movements are decoupled. And we call this covert attention. And that if someone's looking at you, they'll have no idea where the focus of this covert attention is. So overt attention is when we physically shift our eyes to look in a new location. But once we're looking at a particular location, we can then covertly attend above or below or to the left or to the right of that. One of the best examples that I think of in my life is when I'm playing sports and I have to pay attention to multiple things while I'm looking at one particular location. Playing basketball is a good example because you have to pay attention to the person with the ball and the person that you're covering, and to see both those things you likely have to look in a third location. And we can covertly attend places in our visual field, but while we're looking at something, we can also covertly attend to a sound or to a feeling or to a touch that we have against our skin. So the property of attention allows us to do a very important thing. Attention allows us to perceive a subset of the world and ignore the rest of the world. So we're not bombarded with every leaf and every petal and every cloud. We can focus in on the house or the people or the part of the book that we're interested in at the time. And this focus allows us to even improve our perception. So we can treat something as if it was there by itself instead of there with a forest of other distracting things. At the same time, this interferes with the perception of the things that we're not paying attention to. So if you're paying attention to this lecture right now, you're not paying as good of attention to the sounds outside or to the sounds of the clock or the air conditioner or the heater, more likely. We have two ways that we can focus attention as well. We have what's called exogenous attention, where something out in the environment like a bright red fruit or a loud sound will capture our attention. So a big fire alarm going off in the middle of class is an exogenous pull on your attention. And this is going to go from lower to higher levels. So it'll start at the levels that are processing the color, and it will feed into the highest levels. On the other hand, I can give you a task like this, where again you have to find a red O amongst these distractors, but now this task becomes more difficult. It doesn't just pop out like this red circle amongst all these green things. Now you have to actively categorize these X's and O's, and you know to only be paying attention to the O's themselves and ignore these red X's. So endogenous attention means that it's internally driven. The goals that you have for your day or your task drive what you're paying attention to. So I can tell you to pay attention to the hair on top of your head or pay attention to the feeling of your shoes, and your attention will move around based off these goals. So when you look for your keys is a good example of endogenous attention. You go back into your house and you look into every room and all these tables, and you're trying to have this goal about what your keys look like, and you're trying to look for them out in the world. One way that we study attention in the lab is by using these quickly changing scenes where only one minor thing will change between the two instances of the scene. So you can play around with some of these in the PowerPoint slides. They don't seem to be coming through in these recorded lectures, and you can search for change blindness demos. So these are quickly changing scenes where a flash of light in between the two scenes makes our memory of what happened on the previous scene so fleeting that we can't tell big differences in the image. This is a very good indication that we can't pay attention to everything in a scene all at once. That as we look at a scene like this, if only one of these guards is changing, we have to actually have been paying attention to that guard before the change so we can see the change after. So change blindness involves a picture on the screen that changes back and forth, usually every 100 milliseconds or a fraction of a second, and with an interval in between them. So you need an interval in between them so that you need memory and attention to keep the information in mind over the delay. You can also present these side by side, and it also is usually an effective way of getting change blindness. But when you do these demos, you'll notice that it takes often many seconds for you to find these changes, and that when you see the change, it's hard to not see it. And what this shows us is that as we're looking around these scenes, We don't remember what we were focusing on at any given time. We need the very quick relationship between seeing a change and seeing the change in the other image before we'll notice anything. Change blindness is a different phenomenon from a very popular psychological effect called inattentional blindness. You can watch this demo in your own time of a gorilla walking into a room of people playing basketball, and you've likely seen this before. And the results from doing this experiment on hundreds and thousands of people is that about half the people that have never seen a video like this can miss something as salient and as big and important as a gorilla when they're doing something else. Inattention blindness is a disorder, or is a trick of our attention, and that we could be looking right at something and miss it in front of our eyes. Whereas change blindness, the change is something that's already gone, and we have to remember that it has changed. So inattention blindness is often a little bit more powerful of a demonstration of our attention, because the thing is right on the screen. I'll let you watch this card trick video as well, and look for how the trick's done, as an example of, again, the changes that can happen in our visual system. One other aspect of our attention is that we often are kind of covertly processing things outside of our awareness. So if you go to a busy party last weekend, you might be talking to some friends amongst a whole bunch of other conversations in which people are talking, and you're successfully ignoring these other conversations. But then if something of the conversation captures your interest, maybe someone says your name or says something that you're particularly interested in, that can capture your attention. So normally our brain can block out these stimuli just well, but this shows that there's this unconscious monitoring for important things that might happen. How does attention work in the brain? What happens when the spotlight of attention is shined on a particular stimulus? Well, the areas that process those stimuli increase in their activity. So if you're attending to something moving or attending to color or shape, those areas that process that stimulus will become more active, and the processing of the stimulus will be enhanced. Attention can also decrease activity of networks that aren't being used, and that therefore can decrease activity for features that you're not paying attention to. So before you were paying attention to your shoes, the activity from the sensory receptors of your shoes was being inhibited. The classic findings from attention in neuron recording are that if you record from a neuron and you shift that is responsive to a particular stimulus in a particular part of its receptive field, you find that when people attend to one of the stimuli in the receptive field, the neuron starts to fire more. And if the attention is shifted to a stimulus that that neuron doesn't like, the firing doesn't increase in the same way. So attention essentially can boost the processing that neurons already like doing. If I'm a neuron and I really respond to faces, then when I attend to faces, that neuron will respond much more vigorously. If we put people in the fMRI scanner and we get them to attend to faces, or we get them to attend to spatial relationships using very similar tasks, so you use this task where people have to identify which face is the same versus which spatial relationship of the boxes with this line is the same, people get increased blood flow in different parts of their brain. So if you attend to the identity of a face, you get increased blood flow in the ventral stream. If you attend to the position of a face, you get increased blood flow in the dorsal stream. So attention boosts the blood flow to areas that are needed to do the task. Attention also boosts the evoked activity. So if I record from electrodes on the surface of the head and I show people a visual stimulus over and over again, you know that you get the event-related potential, this ongoing increase and decrease in the voltage which is associated with different areas processing the stimulus. Attention magnifies, boosts each of those ERP components. It makes the brain respond even more to a stimulus. I'll continue in the next video.